like to introduce Naveen Suvarnu, who will be presenting Network as Code in Practice, Safer Change Operations with CI/CD, Testing and Data Models. Naveen is a principal architect at Cisco Systems and traveled from North Carolina to join us today. His work focuses on applying CI/CD workflows, structured intent, and automated validation to real-world network change operations across campus, data center, and WAN environments. This is Naveen's first time presenting at Nanog, and it's a pleasure to have him speaking with us today. Welcome, Naveen.
All right, thank you, Mikhail. Hope everyone is having a great Nanog 96. It's an honor to be on this platform. For the next 45 minutes, we're going to talk about network as a code. For those who don't know what network as a code is, network as a code is using software-defined principles to manage and automate your network configurations as code. Now, you might ask, what are these software-defined principles, right? The software-defined principles are things like version control, which is pretty rudimentary to the software development process. It could be things like continuous integration and continuous deployment, wherein you continuously integrate changes to your code, you validate it thoroughly, and only once you're done with your thorough validation that you integrate your code into the main line. Or it could be things like, it could be things like declarative configuration intent, wherein you just specify your configuration intent without getting deep into the semantics of how your configuration will be executed. Now, we have used historically as a code principles to manage our application stack and manage our compute stack. But we have now seen a paradigm shift wherein more and more organizations are trying to use as a code principles to manage their network configurations. So the agenda for today is pretty straightforward. This is my agenda on all my platforms. Everywhere I go and speak, I talk about why, what, and how. So we talk about why network as a code, what does it entail, however I help my customers embrace or enable as a code solution for their automation needs, and then we pivot to a quick demo to put things into perspective. So why network as a code? Network as a code is required because inherently automating network configurations is a complex task. Network configurations as such have a lot of idiosyncrasies, right? There would be idiosyncrasies around configuration syntax. There would be idiosyncrasies around configuration hierarchy. There would be idiosyncrasies around configuration dependencies. And more often than not, these idiosyncrasies or these nuances, they don't not only apply to a given vendor, but they could also apply to different platforms being provided by the same vendor. Now, you might be an organization wherein you have a set of engineers and architects who are good at automation. They've been able to overcome the complexity around network automation, and you create these silo scripts every now and then to help execute or automate day in, day out mundane tasks. But let's understand this, that these silo scripts do not provide you with the capability to do version control. These silo scripts do not provide you with the capability to validate what you're trying to automate and see if it's in line with your configuration best practices or with your enterprise wide standards. So with network as a code, what we are trying to do is we are trying to simplify, optimize, right? So we try to we try to abstract complexity. Those idiosyncrasies that I was alluding to earlier, those are solved using something we call as data models. So data models provide you with an exhaustive list of all configuration attributes that are supported on a given platform. They not only give you a list of all configuration attributes that are supported on the platform, but they also provide you with the key value pair for each configuration attribute. They provide you with a default value. They provide you with a data type for each configuration attribute. More so, data model would provide you with an exhaustive list of all dependencies or all hierarchies that exist between features on a given platform. So that's one, right? You can also make it an opinionated data model in the sense that you could incorporate the default values in the data model to be your vendor-specific best practices. Now, with network as a code, we use Git-based methods. So every incremental change that you make to your configuration is subject to some kind of a merge request or a pull request. With a merge request or a pull request, you have the complete leeway to maintain a paper audit trail of what does that change entail, right? What was requested? Who requested the change? What are the target devices in scope for the change, right? So me as the change owner, if I can look into a pull request or a merge request, get a complete understanding of what changes are being requested, and if it's in line with my enterprise standards, if it's in line with my best practices. And only when I have done my thorough review and I believe that, yes, this is in line with my best practices, that I'll go ahead and allow that change request to get through, right? We, as a part of network as a code, we also support pre-validation and post-validation. Pre-validation is validating the configuration intent before it's rendered onto the target device. And post-validation is validating the configuration state and the operational state of the configuration once it's been executed on the target device, right? So with pre-validation, we do things like syntax and semantic validation. Now you may ask, what is syntax and what is semantics? Syntax validation is validating the data type of the configuration intent against the data model, right? So let's say I'm trying to configure BGP. A BGP AFN can only be a 2-byte or a 4-byte integer, right? Similarly, I'm trying to configure a VRF. A VRF can only be a string. So what I do is I look at the configuration intent, I validate it against the data type for my data model and see if it matches. Only if it matches, I let it get through. The other part is the semantic check. Semantic checks, think of semantic checks as custom rules that you've created for your organization. You might have a request wherein, you might have a standard wherein all access port uplinks or all access switch uplinks should be configured with root guard, right? Or you might have a rule in play or a standard in play wherein you would say that all my multi-hop BGP neighbors should be configured with a BFD profile. So the semantic rule is completely at your disposal. You define what your semantic rule would be. So data model to get, data model is your source of truth, right? You used pull request, merge request, so you have a complete audit trail of who requested when and where and what. And then there is the pre and the post validation, right? So with these capabilities introduced, right, you are deemed to have configuration consistency, you'll have fewer rollbacks, faster service onboarding, clear change ownership, and obviously you have unified, you have one platform to go to orchestrate or automate things end-to-end across your install base. Now let's quickly pivot to, now that we talked about the why, let's talk about the what, right? Terraform or OpenTofu, which is the open variant of Terraform, is the de facto automation engine or IAC tool when it comes to most, if not all, network as a code deployments. There are two main constructs with Terraform. One is provider and one is resource. So provider is basically a plugin that understands how to attach to a device and configure a device. And a provider could be associated with multiple resources. Think of resources as atomic configuration units on the target device. Now, these resources could be physical atomic units or it could be logical atomic units. A good example of a physical atomic unit would be a front panel port on a switch or a router, right? And a logical unit would be something like a VLAN or a VRF. So what you see on your screen is a provider which knows how to log into a router. It uses username admin, the password is nanog123, it has the URL for REST API access, and then REST conf access, my bad. And then you have a set of resources wherein the resources would help you configure VRF and OSPF on this target device. Now, if I were to use Terraform natively, I would have to understand how do I define my variables. So in this case, I'm defining a variable for VRF, I'm defining a variable for OSPF. And I'm defining variables because I have multiple instances of VRF or multiple instances of OSPF process IDs that I would like to configure. So in this case, I have a VRF prod, I have a VRF dev, and I have two OSPF processes, OSPF process 10 and OSPF process 20. So first thing is me using native Terraform, I need to define my variables for bulk configuration. Secondly, I need to define my dependencies, right? So I need to define my loops to loop through multiple variables, and then define my dependencies between my variables. So if I need to associate an OSPF process with the VRF, I'll have to ensure that the VRF is configured first, and then the OSPF process is attached to that VRF configuration, right? So this is native Terraform. You need to define your variables, you need to define your loops, you need to define your dependencies. Now, if I were to use network as a code, in that case, all I do is I define the device that I'm trying to configure. In this case, it's router 1. I'm trying to configure it with VRF prod, VRF def. And under the routing OSPF process, I'm associating VRF prod with ID 10 and VRF UAT with ID 20. That's it. I'm not defining any variables. I'm not defining any loops. I'm not defining any dependencies. So you may ask, how do I achieve that level of abstraction using network as a code? And the answer is that we delineate data from code to provide for that level of abstraction. So your data is still your input YAML, right? This is where your main focus is as a network engineer or as a network architect. This is what you would want to configure on the device, which is, again, a set of VRFs associated with a set of OSPF processes. But the code is represented using two separate files. You use a schema YAML. Basically, this is your data model. And within the schema file, I've defined my VRF feature. I've defined the configuration attributes that can be associated with the VRF. In this case, the VRF name can only be a string. The VRF description can only be a string. The VRF route distinguisher can be a concatenation of, it's a regex, right? So it can be a concatenation of, a 4-byte or an 8-byte ASN concatenated with an IP address. So that's your RD therein, right? And my routing OSPF process, again, I'm defining the identifier, which can be any number between 1 to 65535, and my VRF name, which is a string. So that's my one part of my code, which is my schema. And my other part of the code is my module, right? So what my module does herein, it uses the locals construct in Terraform to go extract my configuration intent from my input YAML file, transform it, normalize it, attach it to the resources in the backend, and then push it onto the target device, right? So I have a clear delineation of data versus code. Data is my input YAML, that's my configuration intent. And my code comprises of my schema.yaml file, right? That's my data model wherein I've defined all my configuration attributes. And then I have this Terraform module that would help me with extraction, normalization, transformation in order to map it to the Terraform resources in the backend. Now, this is the most common CI/CD pipeline that you might encounter every time you were to execute on this solution. The very first step in this pipeline is to commit on your configuration intent, right? Again, the same configuration intent. I have a set of VRFs, I have a set of OSPF processes, I have these processes attached to a given set of VRFs, right? So I have 10 associated with VRF prod, I have 20 associated with VRF UAT. So I do a git commit. As soon as I do a git commit, what that would initiate is the validation step. At the part of the validation step, I would do, the very first thing that I would do is do canonical linting, right? So I'll lint through the entire input YAML, see for, look for indentation issues, look for syntax issues, errors, and things like that. And then I get into validating my data types, right? So I would validate if my VRF name is a string. In this case, VRF-prod and VRF-dev is a string. I'll validate if my routing OSPF process ID is an integer. In this case, it's 10 and 20, so it's an integer. So I've validated my data types, which is your syntax validation. And then I validate the semantic rules, right? So I could have a semantic rule wherein every VRF name should have a prefix of VRF dash. So in this case, I have my VRF name with the prefix of VRF dash. So I've checked the semantic rule as well. So now that I have gone through all my validation through the linting process, through the syntax check, through the semantic checks, the next step is to plan and deploy. And this is where Terraform, in my eyes, I found Terraform to be very valuable because Terraform is declarative in nature, right? So if I were to, specify my configuration intent to Terraform, what Terraform would do is it will go fetch the current state from the target device, come to an understanding as to, hey, if this is what the configuration intent is, and if this is what the target state is, what kind of activities would I need to execute on in order to go from point A to point B? So what it basically means is what kind of create, update, delete operations would I need on my Terraform resources to go from point A to point B. And that is what you get as a part of the Terraform plan. So once you initiate the Terraform plan, you'll get a JSON file of sorts, which will tell you that, hey, in order to get from point A to point B, which is your target configuration intent, you'll have to update or delete or create these resources. You could look into the plan. You could say that, okay, this plan looks in line with my enterprise standards, with my best practices. Let me go ahead and execute. That's when you will click on Terraform apply, right? The Terraform apply would then take your JSON file, right, the JSON plan, and then go ahead and execute it on the target device. Now, once the configuration has been rendered onto the target device, that's when you start testing it, right? So you validate the configurational state and the operational state once the configuration has been rendered onto the target device. And in this case, what we use is we use a set of robot test cases, right? We look at what the configuration intent is. We create corresponding robot test cases on the fly, and we go ahead and check the configuration state and operational state. So in this case, I'll go ahead and verify if the two VRFs have been configured, if the two OSPF process IDs have been configured, and if the process IDs have been associated with the VRF instances, right? And let's say I was expecting 4 OSPF adjacencies on each one of my process IDs. I'll go ahead and check the operational state if there are 4 individual adjacencies with both process ID 10 and process ID 20. The last step is to notify, right? This is where you basically could have integration with Teams or WebEx. For that matter, you could have a webhook to your ITSM tool, right? And you would, whatever artifacts that you've collected as a part of your validation, as a part of your planning, as a part of your application, as a part of your testing, you will basically take all of those artifacts and pass it on, right? So that's your paper audit trail that I was alluding to earlier. Now, a word of caution, in a real world deployment, you would, whenever you execute on your CI/CD pipeline, you would execute it on a test environment first, right? So I'll create a test feature branch, right? I'll go through the same series of steps, which is validation, planning, deployment, testing, notification. And only when I get through all of these steps, and I believe that, hey, the incremental change is ready for prime time, that's when I merge it into the mainline branch. So you do the test environment first, and then you merge it into the production. This is the overall reference architecture for network as a code. At the bottom of the stack, you have the infrastructure, right? It could be data center, campus, WAN, virtual, cloud. On top of it, you have the source of truth. Source of truth is the Git repo wherein you store your configurations. It's the repo wherein you store your CI/CD pipelines. Your automation engine is the engine that actually executes on the job rendered by your CI/CD pipeline, right? So in this case, your automation engine could be Ansible, Terraform, OpenTofu. Now, the entire network as a code solution has a northbound API layer, right? So if you would want to have any kind of northbound API integration, let's say you have a use case wherein you have a multi-domain use case, right? Wherein you want the VRF to be rendered right from your data center onto your WAN, onto your campus. In that case, you have multiple touch points to go automate, right? So in that case, you might use a workflow engine to automate your end-to-end logic. And that you could use any workflow engine for that matter, and that workflow engine could use a northbound API provided by network as a code to use the CI/CD pipelines to go execute against each one of those domain controllers, be it in the data center, be it in the WAN, or be it in the campus, to execute on your intent. Now, you could also use that northbound API to go talk to your ITSM tool, right? Or you could use that northbound API to go talk to your agentic AI or AI assistant for that matter. So that's your reference architecture. Now let's quickly pivot into the how, right? Every time I've given an opportunity to go help execute or enable the solution with my customer, as I hit the ground running with the customer, the very first step that I do is do a thorough assessment, right? Get an understanding of what tools, means, methods, people, processes exist, right? What is the install base like, right? Get an understanding of, hey, what are those use cases that the customer could possibly benefit from by using automation, right? After I've done all of that assessment, the next part for me is to set up the infrastructure to support automation, right? This setting up the infrastructure could be, repurposing their existing DevOps tool, or automation engine, right, to provide for network as a code capabilities, or it could be providing them with a plug-and-play OVA that has all the open source tools that I need for network as a code right out of the box, right? Once the infrastructure piece is done, then I work with the team to get an understanding of, okay, what kind of east-west or northbound integrations would be required, right? You might have, a customer might have an existing source of truth, right? They might use things like NATO-box or NetBox, and they want east-west integration with that particular tool. They might be using an ITSM tool, and they would want to integrate with ITSM as a part of the overall process. So that's when I work with them on the integration part. And right after I've done the integration piece, that's when I start now working on modeling the configuration for the use cases, right? Modeling the configuration for the use cases per the data model. Then we get into the execution phase, right? So we start small, we start in a small enclave, and we grow horizontally. I would be in the driver's seat to execute the very first set of use cases with the customer looking over my shoulders. And only when the customer believes that they have a thorough understanding of the process and they have confidence in the solution, that's when we pivot, right? Now the customer would look over my shoulders, and they, I would look over the customer's shoulders and they would execute. So here, and if you look at the change process, it's the same thing, right? I start with introducing a test feature branch, right? Have it go through the steps of validation, planning, deployment, testing, right? Only once I am confident that yes, this looks good in the test environment, that's when I merge it into the mainline branch. Once you merge it into the mainline branch, it will go through the steps of pre-validation, right? It will go through the canonical linting process. It will go through syntax check, semantic checks. And that's when, once everything looks good therein, you'll introduce a webhook towards your ITSM, upload all the artifacts onto the ITSM tool. Now you'll have a change owner who'll go onto the ITSM tool, approve the request, and that's when you'll start with the deployment process, right? That's when Terraform will go ahead and deploy your change down. Followed by the post-validation, obviously, right? And this is a vicious cycle, right? As I said, we start small in small enclaves, and we grow horizontally. I execute to begin with, then I pivot. Customer starts executing once customer has confidence in the process and the solution. Now let's look into a quick demo to put things into perspective. As a part of this demo, my configuration intent is to bootstrap a set of access switches right from zero configuration to full configuration using network as a code processes, right? Okay, so here is my input YAML, right? My declarative configuration intent. Here, in the very first thing that I'm trying to configure is the global variables. As the name suggests, global variables remains consistent across all my devices, right? So there are things like logging, SNMP, things like NTP, which remains consistent across all my devices. I have static routing with the default gateway set on each one of these devices, and again, that remains consistent across all my devices as well. Next, I pivot to configuring device groups. I have a set of device groups for floor 1 access switches and a set of device group for floor 2 access switches. Floor 1 access switches have a set of dedicated VLAN IDs. In this case, it's VLAN ID 10, 20, and 100. Floor 2 access switches has a set of dedicated VLAN IDs, which are VLAN 30, 40, and 100. And then I have a template, I have access switch template and access security template. These templates remain consistent across all my access switches with some floor specific variables, right? We'll come to that in a bit. I have interface groups configured. I have a dedicated interface groups for my uplink ports. I have a dedicated interface group for my access ports. So I have a floor 1 uplink, a floor 2 uplink, right? Different set of VLANs. I have a floor 1 user access port, which is VLAN 10. I'll have a floor 2 user access port, which is VLAN 20, VLAN 30 if my memory serves me right. And then I have the printer ports, the device access ports, which is again VLAN 10. And floor 2 has VLAN 30. And then I have a set of wireless ports, which are trunk ports with those two VLANs, 10, 20 allowed for floor 1. And floor 2 is 10, 30, 40. Now, I could have shown you a very simple configuration set, right? With just NTP, syslog, call it a day. But I wanted to show you what the art of possible is, right? By showing you the entire hierarchy here and nested configuration, this is what you could possibly achieve using network as a code. Not saying that you necessarily have to do it. It's something that is possible. These are my security templates. So I'm disabling source routing, I'm disabling domain lookup, and enabling password encryption, regular stuff, right? Now, because I have included most of my configuration in a templatized manner, in the master template, my access switch template would be minimal, right? So here I'm trying to configure an access switch. It's a floor 1 access switch. It belongs to floor 1, right? I'm just specifying the ports. In this case, gigabit 1/23 is an uplink port. Gigabit 1/24 is an uplink port. Port number 1 is an access port. Port number 2 is an access port. Port number 3 is a printer port, right? So it's configured with floor device access port interface group. And then there is the port number 11, which is the wireless AP port interface group. The same set of configurations exist on access switch too, right? Again, because I've used a lot of templatization as a part of my master template, my device-specific configurations are very minimal. I'm just specifying what floor does the device belong to, and this just associating those interfaces with the uplink groups or with the access port groups. And this is my schema definition, right? This is where I define all possible configuration attribute, define the data type associated with the configuration attribute, the default values associated with the configuration attribute, right? So this is my entire, and I have this across the stack for all possible attributes that would exist on a given platform. What you need to understand is while that access switch YAML, input YAML file would be your responsibility, the schema and the module, I talked about delineating the data from the code, right? The data is the input, YAML, your configuration intent. The code part, which is the schema part, and the module part would more often than not be managed by your vendor. Here are the two switches, right? They are right out of the box, no configuration on them whatsoever. They're completely blank, except the default configuration. So none of the ports have any configurations on them. Same thing with switch 2, no configuration whatsoever. At this time, I go ahead and stage my configuration. I do that using git add, and then I commit my configuration, right? So in this case, I commit it as nanoc demo. And I now push the configuration to the origin. As soon as I push my configuration and commit it, I should see a pipeline being initiated. So I see that the pipeline being initiated, it has 5 different steps. One is validation, one is plan, deploy, notify, test, and then notify, right? So the validation part is complete, which means it went through all the syntax and semantic checks. The plan is generated. As I said, the plan would give you a complete understanding of what resources need to be created, updated, deleted to get from point A to point B, right? So in this case, it says I need 50 to add, 0 to destroy. So I'll be adding 50 new configuration elements as a part of resource configuration, right? And I can, as a change owner, I can look into my Terraform plan, right? I can go through every line item that exists on my Terraform plan, see if it's in line with my best practices and my enterprise standards. Only when I believe that, yes, it looks good, that's when I go ahead and deploy it, right? So I can click on the deploy button. Now what it would do is it will take that Terraform plan, that 50 odd objects that it needs to add, and render it onto the target device, right? And you see that the configuration has been pushed onto the device, right? So it's floor 1 access switch. The floor 1 access switch is only expected to have floor 1 specific configurations, right? So in this case, the host name is floor 1. It has IP routing. It has the domain name configured. It has DSCP snooping. IC VLAN 10, 20, and 100, which is only specific to floor 1, being pushed onto the device. I have interface 1 and 2, which are workstation ports. Interface 3, which is network printer, which is very much aligned with my configuration intent. And port number 23 and 24 are my uplinks. SNMP, logging. Similarly, on switch 2, you see that the host name changed from switch to floor 2 access switch. Again, floor 2 specific configurations will be pushed onto the floor 2 switch, right? In this case, my VLAN IDs should not be 10, 20. The VLAN IDs would be 30, 40, and 100. My uplinks are 23, 24 are configured with VLAN 30, 40, and 100. And I can now look at my test results, right? I use robo test cases to go execute, validate the configuration and operational state once the configuration has been rendered onto the box. So PABOT is used for concurrency, right? So I look at all the test cases that were triggered, the robo test cases that were triggered based on tags, right? So I see 40 odd test cases were executed on once the configuration was pushed onto the box to validate the configuration and operational state for the configurations. So that's all the tests, the robo test cases that I executed on, right? Now let's say, I am a naive user, right? And I am not privy to my enterprise standards or my best practices, right? I go ahead and configure my uplink to not only include VLAN 1020, but also include VLAN 11 and 21. Again, per my enterprise standards, floor 1 should only be 1020. But I'm a naive user, and I've made this mistake of configuring VLAN 11 and 21 as a part of my configuration intent, right? So now, if I were to push this configuration, commit it, I'll commit it as semantic check, right? I would expect this pipeline to fail. I see that the pipeline has failed in the validation stage, right? And it would, if I were to look into the logs, it will tell me that there is a semantic error against rule 1 or 2, wherein for the floor 1 access uplink trunk, the expected VLAN IDs were a list, any item in the list of 10, 20, 100, but what has been configured is 10, 11, 20, 21, and 100, which is incorrect, right? So this goes back to the semantic validation piece, wherein you could basically come up with your own custom rules, right? You could say that, hey, if this particular configuration, I have a rule in play, I have a set of rules in play, and if there is any conflicts with any of the rules that I have stated as a part of my policy set, do not allow the configuration change to get through, right? So that's a part of validation, right? So herein I had a rule created, a rule called 1 or 2, which is trunk validation, wherein I've stated that the expected VLANs for floor 1 can only be 10, 20, 100, and the one for floor 2 can only be 30, 40, 100, and any violation would not be allowed to get through. That's the semantic piece. With that, that brings me to the end of my presentation. I'm now open for any questions you may have.